It is 10 a.m. Pacific. Welcome to all of you who have joined this webinar from Impetus Technologies. Good morning, good evening, wherever you are, and hello if you are listening to this as a recording. My name is Anand Venugopal, and I'd love to welcome you all to this webinar presented to you from Impetus Technologies. So we're delighted to bring this discussion today on real-time streaming analytics based on Apache Storm. And as part of this discussion, we're also, as promised in our promotional emails, going to bring to you some comparative perspectives on Spark and Storm and show you a demonstration of this product that we're calling StreamAnalytix. So this webinar is being delivered as part of our continued effort to create leapfrogging advantages for our customers who are enterprises and to advance the marketplace of cutting-edge solutions and particularly focused on real-time streaming analytics in this case. A brief introduction of our speakers. Our subject matter expert here today is Dr. Vijay Srinivasa Agneeshwaran, Director of Technology and Head of Big Data R&D at Impetus. His R&D team focuses on big data governance, batch, and real-time analytics, and paradigms for implementing machine learning algorithms. He's a professional member of the ACM and IEEE senior member. He currently holds 2 U.S. patents and has a few more filed in the U.S. and Europe and India. Vijay has been a speaker at several international conferences, including our own Strata O'Reilly here in the Bay Area, and his work has been published in IEEE Transactions and other leading journals. My name is Anand Venugopal. I'm the Senior Director of Business Development and also the Product Manager for the recently launched StreamAnalytix platform that we'll be showcasing here today also. I come from a techno-business background in telecom, interactive entertainment, and high-tech industry verticals, and I've been in Impetus since 2010. And as part of the journey here at Impetus, I've been working with IT and line of business executives in large enterprises, helping them to understand and extract the enormous value embedded in their static and in-motion big data assets. So that's about the speakers today. Before we begin, a few housekeeping items. All our attendees will be on mute. You'll be able to hear the audio broadcast using your machine's audio system. There is a provision to ask questions by sending them to me and our presenters. We'll take them up at the end of our presentation today. If you have any issues with the audio or video clarity, just send us a message or email us at event@impetus.com. We recommend you view the presentation in full screen mode by using the option on the bottom left of your screen for best display of charts and images. So, moving over to the agenda, as I mentioned today, we'll be talking about a quick backgrounder on streaming analytics. You're all here, of course, because you're already interested and sold on that space overall. We'll be touching on the streaming analytics options, particularly in the open source space, and showcasing StreamAnalytix and moving on to the Q&A. First, let's look at this set of perspectives from the leading analysts. Forrester said that a 2014 survey data revealed 66% increase in the firms using streaming analytics in the past 2 years. You can see the slide for yourself. We don't need to read it all. In our experience, folks, as we engage with enterprises at least 3 to 4 times a week these days, this is becoming even more real and in the face for us. The people have bought into Hadoop, bought into the big data promise, started in their implementation journeys, and very rapidly adding real-time streaming analytics as part of their core data architecture. And we're talking about the biggest names in the world. So a little bit on the business value of streaming analytics. Why would the business be interested? As we all know, and you might have seen this in other webinars that we've done earlier, the business value of analytics and the business value of data dramatically falls non-linearly with time. The best value is obviously if you can predict events beforehand. And the next level would be try and get exposure to those events and information as they are happening, as they just happened, just the last second, just the last millisecond. And finally, we are at the lowest level of value is looking back in the rearview mirror, right? Descriptive, diagnostic, analytics, more in the domain of BI. So, and the drop in value is nonlinear. So, just to punch in that value of real time and why real time is so valuable. On another dimension, we have again showed this before. The business value of streaming analytics is very clearly available in multiple dimensions from a business perspective, and we have use cases in each of these categories. So what you're seeing here is a pyramid of the categories of use cases that streaming analytics can contribute to. There's a number of use cases in different industries where it helps in cutting preventable losses by predicting potential failures that are millions of dollars in terms of cost. Streaming analytics is also used in routine operations in terms of operational intelligence, in terms of networks, in terms of trucking fleets, various operations including security events, etc. And we're seeing more and more enterprises also beginning to try and leverage missed opportunities, like customers being on your website wanting to buy something and you're not offering it because you don't have the context, and adding a real-time context to both e-commerce as well as customer service to provide the consumer a rich experience and thereby, of course, increase revenues. And there probably are also a number of brand new opportunities that have never been tapped before that streaming analytics enables. And we elaborate all of this in another webinar that has been delivered earlier and is archived on our website. Feel free to go and look at that and listen to that for a detailed exposure of all of these layers of the pyramid. Now, with that brief introduction, I'm going to set it up for Dr. Vijay to come in and handle the core of this presentation here. So what we're about to see is a brief perspective on the different open source options for stream processing delivered by Dr. Vijay. Vijay, are you online?
Yes, I am. Thank you, Anand.
Great.
So let's look at some of the alternatives in this space first. After S4 is the complex event processing engine from Yahoo. While it's again an emerging piece of technology, one of the main issues in S4 is that it does not guarantee that messages are delivered exactly once. So there's a possibility of losing messages in S4. Millwheel from Google is also a very good problem technology from Google. However, it's not yet in the open source, so we are keeping track of it, but yeah, we'll watch out and we'll be looking at it in future. Samsa is again an emerging piece of software from LinkedIn. Samsa was really hard to use when we did it ourselves. We had some difficulty, especially in using the APIs and being able to program it, so it still is not enterprise ready. So clearly the top two contenders are Storm and Spark Streaming right now for us. So we focus the remaining part of this webinar on these two technologies. So we can go ahead and do a detailed comparison between these two. Okay. Yeah, so one of the things, the main points we should note is that Storm can process individual events as and when they are received. Contrastingly, Spark Streaming, which is the streaming component in the Spark world, so I will henceforth we will use Spark Streaming. So Spark Streaming will batch a set of events and process them deterministically. There is a fundamental difference in terms of processing. So the point here is if, and as may be the case in several use cases that we have also seen, the point is there is a need to process individual events and have event-specific actions taken as soon as they are received, in which case Storm would be ideal. So the same can be achieved in Spark in a slightly different way by lowering the batch size to be sufficiently small. So this is the basic difference in processing between these two technologies. In general, we have observed from our own studies also, and it's also in the observation of several others as well, that Storm is a low latency engine, whereas Spark streaming is seen as a high throughput engine. So by low latency, I mean that the time required to process individual events is going to be really small, whereas Spark streaming might be able to process more messages over a period of time because of its ability to batch and process them as a group. So this is the fundamental difference between these two things. In general, one of the main things is you should keep in mind that a number of use cases which have come our way has been for low latency systems. So that seems to be a common use case in the stream processing world. In terms of availability, both are now available over, both work over Yarn and Mesos. So there's really no difference here. We could move on. This is an important point because one of the things one would like to do is to be able to do complex event processing and run SQL-like commands. So this inherently is possible in Storm using the Esper software, which has been well integrated into Storm. The same is possible in the Spark streaming world by using Spark SQL, which works on top of Spark streaming. However, Spark SQL, especially for the streaming data, is still in beta. So this, for example, there are a few methods such as, there is a method to initialize or load a row of the data as and when it arrives, right? So the way to go about it, you would make an RDD, which is the resilient distributed data set in the Spark world. So the RDD would become like a table, and you would insert into. So insert into is the method which has been implemented, and you would insert one row into the table, right? But however, the insert into currently does not work on the RDD. So you have to use a Parquet file as a table and then use it. So there are little, these are very subtle things, but Spark SQL is not enterprise ready yet. So that's the final message we are giving. In terms of intermediate storage, Storm uses 0MQ and of late NetE as well as the option, while Spark streaming uses in-memory storage and uses RDD. Spark also uses Java, NIO, and NetE internally. So there's really not much difference here. So this is another important point where basically the idea is, can we run sliding window kind of queries and be able to perform joins on the windowing themes as and when they arrive in. So this becomes possible in the Storm world through Esper, whereas Spark streaming offers an inbuilt inherent support for that. So that's the difference. So another point where Spark streaming has a slight advantage is that the Lambda architecture, which is all about you unify the batch and the stream computation. So in this case, in the Storm world, one would have to have a separate pipeline for the batch processing, for example, over Hadoop or using other technologies. But Spark streaming could unify both kind of computations very easily. So in terms of message processing semantics, both achieve exactly once messaging. This is done in the Storm world through Trident, which is the transactional messaging system over Storm. Spark streaming does it through the RDD lineage concept.
It's probably useful to mention that by default, Storm is at least once, and Trident helps in making it exactly once, right, Dr. Vijay?
Absolutely correct, Anand. So basically, there is a possibility of duplicate messages without the use of Trident, but using Trident, one would achieve the same exactly once messaging that you're doing on the Spark streaming world. In terms of fault tolerance, Storm is highly fault tolerant. It uses Zookeeper and stores the state of the system in the Zookeeper cluster. Spark also provides fault tolerance to some extent. It allows the lineage information to be stored into the Hadoop distributed file system. but there is a cost of recovery which is a little higher there compared to the same in the Storm world, which would possibly recover from zookeeper much faster than what's possible in the Spark streaming world. So essentially, these are the differences. The number of production deployments is pretty much higher in the Storm world compared to the Spark streaming. There are a few emerging deployments for Spark streaming, but Storm has been around much longer and is consequently having more production deployments. So all in all, right, we can kind of summarize and say that while Spark streaming is an emerging technology and has certain advantages in terms of providing a unified pipeline for batch and stream computations, as well as a very elegant sliding window concept, there are still certain advantages for Storm, and mainly being that it's a low latency system, it can process individual events, it's highly fault tolerant, and the number of production deployments are much, much higher. So all in all, we are going to keep track of both things, and definitely Spark streaming is an emerging one. Right now, Storm is enterprise ready, and Spark streaming is not. So we are going with Storm. So that's the message we would like to deliver today. Over to you, Anand. Anything else I should be adding?
So, Dr. Vijay, I think thank you for stating that. What we're seeing, let's share with you what we're seeing in the marketplace today. As Dr. Vijay mentioned, we're clearly watching out for Spark streaming with very, very credible technology. But from an enterprise readiness perspective and from what large banks, large telcos are doing, there's clearly what we're seeing more on the ground is Storm. And as you see in this graphic, StreamAnalytix is designed to give you a future-proof option with these technologies. Today, StreamAnalytix, the enterprise-class streaming analytics platform that I was just about to introduce to you, is based on Storm, and our vision is to abstract the enterprise from these choices. So we want to give the benefit of the open source world to the enterprise, but have the customer, that's you, be free of selecting one or the other at what point of time. Whatever is enterprise ready will be abstracted under StreamAnalytix. That's the vision. So with that, let's just go deeper into the vision of the StreamAnalytix product itself. We're into 20 minutes into the webinar at this point, and we also have a demo to show you. So let's put ourselves in the shoes of the enterprise customer. What are their default approaches today to streaming analytics? On one side, you have proprietary platforms. There are a number of credible products out there, but unfortunately, they're proprietary, and they would lock you in from a vendor lock-in perspective, because they're largely proprietary, even though they are maybe working on Hadoop. The core streaming technology could be proprietary. So you don't get to leverage open source. The cost could obviously be high because the R&D cost would have to be manifested as pricing and premiums to the customer. And with any proprietary technology, there's limited flexibility for customers to play around, extend, etc. The product vendor would pretty much dictate that. Now, on the other hand, what is your other option, right? So we're all talking about Storm and Spark here. So you obviously have a do-it-yourself option, where you go in, work with the native open source system, which is Storm or Spark streaming, whatever that may be. But you're kind of exposed in that you may not have vendor support. And you certainly are going to spend a lot of time doing integration and long-term maintenance. I mean, what if the two versions of your messaging queue and your streaming system get out of sync, right? What if your version of HBase doesn't work with the right version of Storm versus with the right version of Kafka, things like that, right? So all of that burden is onto you, the enterprise user. And net, you obviously need deep expertise with folks who understand these technologies in and out. And you're still talking 12 to 18 months in terms of delay, in terms of time to market, to really get something into production-grade systems. So what is the vision of StreamAnalytix? Why are we offering something here to you? we want to offer you the best of both worlds, the third approach. So StreamAnalytix mitigates the disadvantages or downsides of each of the two default options and brings to you the best of the two worlds, which is enterprise class and open source. So you get to participate and benefit from the open source system advantages, community innovation, no vendor lock-in, low cost, and you're future-proof. And on the enterprise class grade technology, you want to have a reliable, manageable, scalable, vendor-supported product which has a pretty good support with professional services, and you're able to extend and customize. And that's what StreamAnalytix brings to you. So StreamAnalytix, for those who are totally new to this, can be looked at as an app server for real-time applications where the enterprise gets to focus on your business logic, leave the complete infrastructure problem to the platform, and this platform obviously helps you to deal with all the three V's, volume, velocity, and variety. And as I said earlier, easily 12 to 18 months of time to market acceleration compared to doing it all yourself. And it seamlessly does integrate with Hadoop and NoSQL, as you will see going forward. So quickly in terms of the block diagram for what is StreamAnalytix, how does it look, how does it fit in terms of an architecture. The golden brown components on this slide represent the pieces of StreamAnalytix. You all are probably very familiar with Hadoop. You probably have a Hadoop cluster going, and many of you probably have Storm. So this first version of StreamAnalytix is clearly directed and targeted at the Storm community, where you can build streaming analytics applications on Storm rapidly with this infrastructure we're providing. So what all would you think of, what all would you need, right? You need to integrate with queuing technologies such as Kafka, RabbitMQ, and potentially other proprietary queuing technologies. We make it very easy for you to do that. It's pre-integrated with Kafka, RabbitMQ, and we could easily build. Customers are asking us on a weekly basis about probably one or two other different options that they have in their environment. We can easily build a spout in Storm that can receive the appropriate queuing technology if it's not one of these two. Now, the data comes in and into Storm, and StreamAnalytix, as you can see in that core middle piece, provides a container for applications running on Storm, right? So the App 1, App 2, App 3, and App 4 are applications that you would build on Storm that would execute in Storm, and we make it drop-dead easy to do this. And we're going to show you today a particular app that we've built in on the platform. Consider that App 1 circle is log analytics, right? We've actually built a log analytics application, and we'll show you a view of that running on the platform live. So what else do you need as an application developer on Storm? You need some kind of a distributed cache technology for shared state solutions, and also we've built a distributed off-heap cache to enhance performance of the whole system. Also, as an application, you would want to stream real-time data and summary results into a real-time UI, into a real-time dashboard. We make that infrastructure available to you with that WebSocket lying out there and streaming that to an app UI. Now, where would you persist the data? You obviously need abstraction and some kind of facility, easy facility to actually store the data, index the data. So the data then eventually persists in a NoSQL database. Although it says HBase here, we actually come with the product comes to you pre-packaged, pre-integrated with HBase, Cassandra, and Oracle NoSQL. So those are the three options that are pre-integrated, pre-tested, and there's an abstraction layer that helps you to conveniently build any other type of interface as a choice for your persistence. The current version of the product, in terms of moving on to indexing, Elasticsearch is the first indexing system that has been integrated into StreamAnalytix. So we have a nice abstraction engine again that abstracts between the indexer, the Elasticsearch, and the NoSQL database. So on the data query side, when you're reading the data, the query engine that you see here is abstracts the NoSQL database and indexer. So from a UI, you're rapidly getting real-time access to data from the index. The query engine correlates the index with the actual persistence database. So you have a blob sitting in the persistence database. You have and you have an index on the other side, and you can drill down and start viewing data the moment it comes in. The StreamAnalytix UI is what lets you see the whole thing, configure all of the topology, etc. And that's what you'll actually see today shortly in the demo. So without much ado, I think we move to the next step. And just before I go, the cluster provisioning tool you see there comes with the system as an option that you can purchase with StreamAnalytix. It helps you to automatically install visually the whole system, and we would either you have the choice to completely install Storm and Hadoop and Xbase all from the scratch, or we can sit on an existing installation of Storm. We can sit on an existing installation of HDP, HDP 2.1, which is the Hortonworks Distribution Platform 2.1, which has Storm on it. So in terms of just a quick view of all the features, so there's high-speed data ingestion, elastic scaling, so the system scales elastically. We have benchmarked to millions of events per second on just an 8 to 10 node cluster. Data parsing is handled by, we support JSON, comma separated, and regular expression type inputs. Pluggable persistence, I just talked about. You can persist onto HBase or Cassandra or any other fast ingest database of your choice, and we can work through the custom integration required if necessary. But the abstraction layer essentially abstracts the application developer from all of that. So real-time index and search, dynamic message routing, which is something that you cannot do with just native Storm. You build a topology, it's static. If you want to change it, you got to bring down the topology, change it, and then bring it back up. We have the provision here that we can build multiple subsystems in Storm, connect them, and do dynamic routing between them. So you can actually have live application upgrades without any downtime. So we have a convenient rule-based alerting system where you would set up rules and alerts on your streaming data. You have a pluggable workflow, so every event based on conditions, you can trigger external workflows. The fault tolerance and data integrity built into the system with the stack as well as what we do on top of it. And there's a number of optimizations for high performance that we've built in to ensure that there's very, very low latency in your stream processing application. So over to Puneet Shah, who is the third panelist here today, who is the product development lead for StreamAnalytix, to do a demo of StreamAnalytix here.
Thanks, Anand. I'll just share my desktop. As Anand mentioned, the StreamAnalytix platform ships with an admin UI. It's a web-based UI where you can log in and build your entire real-time streaming applications. In this demo, we will look at some aspects of this admin UI of how easy it is to build and configure a real-time application. And in the second part of the demo, I will show a log monitoring application which is built on this same platform. As part of building a real-time application on this platform, there are a couple of steps involved. The first step is creating a new message. By this, what we really mean is entering the schema information or the meta information of the incoming messages that the real-time platform needs to ingest, parse, and then apply alerts or index, save, all those different operations. As I click on the Create New Message screen, we type the message name. We can select the various different message parser types, delimited, JSON, regular expression. As Anand mentioned, these are all out-of-the-box parsers supported. The next piece is selecting the various different fields that form a part of the incoming message. If any of these fields are not present, you can very well add new fields by clicking on the Add New Field screen there. The platform supports granularity at individual field level. That is, I can control at every field whether I want to index it, persist it. While persisting it, do I want to encrypt it? And when saving it into a NoSQL, which column family do I want to save it? All these different options are available for a user to configure from this web UI. The intent is the platform would take care of doing all these settings on these underlying tech stack and abstracting this entire layer from the developer. Next would be specifying various persistence policies. Would you like to do your region splits if it's H-based as your NoSQL data store? Would you want the system to do it, or do you want to specify your own custom logic for region partitioning? Do you want to generate your own row keys or let the system do that, looking at the data, compress it, and so forth? Similarly, you can also specify the indexing policies. How many shards, how much of a replication factor for that particular index do you need, etc. Once you create a message, the next step would be defining the alert rules. I click on Create New Alert. I select one of the messages that would be part of the previous step. For example, I select the custom Apache message. It brings me to the screen. Here we see the list of all the fields that are part of that message. I can create alert rules on using any of these fields. For example, if the HTTP agent contains Firefox and the number of bytes are greater than 100, generate an alert. So as I kept selecting these different options, we saw an expression that was getting built. What this really means is every incoming message that comes into the platform will apply this expression, and if this expression is met, it would trigger an alert. The platform also supports generating alerts on a moving time window. For example, if I say it occurs 10 times in a window of 120 seconds, in other words, what it means is if this particular expression, this is met 10 times on a moving window of 2 minutes, only then trigger an alert. So the platform supports alert generation on every individual message or generating alerts on a moving time window. As part of the description, I can enter any description message and use all these different fields of the message, and at runtime, these placeholders would get replaced with the actual message value. I can select various different workflows associated. For example, I selected an email workflow. So what would happen is the moment an alert is triggered, this expression is met, it would execute this associated workflow. And as part of this example, it would send out an email to various people who are added in the 2CC list, etc. The platform supports associating various different kind of workflows as well. For example, if you need to send out an SMS, if you need to invoke a web service, if you need to publish it to any other Kafka, RabbitMQ, any of these different queuing mechanisms so that a downstream system can consume, you can very well create those workflows and associate it here. Next, I shall switch to a log monitoring application that has been built on the same platform. I'm logging in. What we see here is the dashboard of the log monitoring application. On the top, we see some quick links. I'll move on to the system monitoring screen for a moment. Here we see the CPU utilization, the memory utilization, the disk utilization of a particular host. Over the last hour, I can select any of these time ranges. I can zoom in into a particular data point of interest. I can also perform search of the log events that the system has already captured and indexed. In order to demonstrate the real-time aspect of the system, I am going to generate a couple of events out here. We see this red pop-ups appearing on the top right corner of the screen. These are the alert visualizations that we have built. We have configured an alert rule which says that the Apache web server log returns a 404 response code, generate an alert. And the moment the alert is generated, it sends out a message via WebSockets to this web browser. And as part of visualization, we create those red pop-ups. So I'll generate a couple of more of these events. Again, I do a search. We see the count increase from 278 to 283. I can click on it, and it shows me the messages, events for those 283 response results. Out here, I can select any of these different fields, and as I keep selecting them, the grade gets updated with those individual field values. So what happened really was when I made a request to the browser for a particular URL, a log event was generated. The StreamAnalytix collector agent, which is residing and running on that particular remote node, captured that log event. It sent it to Kafka. From Kafka, the StreamAnalytix real-time platform took up the message, parsed it, extracted different field value combinations out of it, applied the alert rule that was configured, and if that got met, it executed the appropriate workflow, and in parallel, it also indexed it. So, on a very high level, this is the demonstration. Over to you, Anand.
Super. So, thank you very much, Puneet, for that demo. Let's move forward and look at a couple of quick aspects here. So, very often we come across this question saying, hey, you built a great stack here, Kafka, Storm, Elasticsearch, etc., and we're also implementing the same thing. What exactly are your value adds? You saw the value adds in action right now. There's actually a lot more. There's an entire screen of building out a Storm topology visually that we're not showing you in the webinar today, and we'd love to show you that in more one-to-one engagements. But we've done performance optimization at the system level. We've done performance optimizations. There's obviously a monitoring and automation full provisioning system you get. There's a complete pre-made system integration of Kafka, Storm, the indexing, persistence, alerting, CT framework, all of that you're seeing here on the slide here today, and admin tool. On Storm itself, this slide shows you a value add that we've created, right? So there's actually a beginning of a multi-tenancy feature where different departments can build Storm topologies and applications, and they're all sharing the infrastructure, but they can't see each other's data, they can't see each other's topologies. So this system allows you that. There's complete visual definition of all the messaging formats. There's visual definition of alerting, just like you saw. One of the interesting features that many customers have asked us about PMML, hey, what if I build models in SAS and R? Can I run that on Storm ready-made, or do I have to build the whole model again on Storm? Yes, you can actually build in a predictive model on R and SAS and export it as PMML and import it on Storm with our facility here. We have a UI that enables you to do that. Just pull the PMML model and implement it on Storm. We've implemented the libraries as well for various predictive analytics algorithms. So there's another question we've got from customers saying, hey, this is great. You helped me to build a topology. You helped me to get going with my Storm application really quickly. What about my daily hassle of managing the Storm pipeline, the application running on Storm, monitoring performance, etc.? That is another area that we've built into this. There's a limited amount of visibility we can give you in a public event like this. We are showing these features to customers. They really love it, especially folks who are working with Storm already and have 30, 40 node clusters. So there are patent applications being filed on various features that I'm describing here, and once that is done, we'll be able to actually showcase that in a more public way. So moving on, finally, you already saw the value adds over open source. The final one is the persistence and indexing. We went over that, and of course the real-time visualization. So as an application developer who wants to create and deploy applications on Storm and then manage that, there's all of the entire life cycle that we have thought through and made that possible with this system. For those of you who are looking at potentially purchasing it, the licensing model has different dimensions that we control and enforce, but the core of it is the quantity of Storm cores. So we license based on the quantity of Storm cores that are used in the cluster, and there's naturally a time-based dimension. There's functionality also that we can control. So that's the licensing piece, and we're we're now ready to address some of the Q&A here. And really, before that, thank you all for listening. We've seen a lot of questions coming through. We're going to begin to address a few of that as we speak here. So, Vijay, one of the first questions that we got through is, some level of stats that we can share in terms of latency and throughput between Storm and Spark. And you can briefly address that. I think the window of batch is what dictates that, but go ahead and address that, Dr. Vijay.
Yeah, sure, I can do that. So we do have some stats to actually show this. For example, on some of the talks that we have done, which includes running certain machine learning algorithms and being able to analyze the data, we figured out that Storm could take only 3-4 milliseconds to process a single message, whereas the Spark streaming could take up to 10 milliseconds to process the same. Similarly, with respect to throughput, where we compared these two systems with respect to similar analytics application where we run certain machine learning algorithms and analyze the data, the time taken to process, for example, 2 million messages on a cluster of nodes would be about 30 seconds on a Storm cluster, but only 15 seconds on a Spark cluster. Meaning that bottom line is that Storm is a very low latency system. Spark streaming is higher latency system, but can achieve higher throughput. So that's what I wanted to say. But in a lot of cases, I think Anand can talk about some of the use cases that we've had, but most of the use cases are where low latency is very important for the system. So that's where Storm would score over. Right, Anand?
Absolutely, Dr. Vijay. Thank you for addressing that. And as you said, yes, I mean, most carrier customers, telco customers, etc., that we're looking at today are using this for an event-based paradigm where they really want to trace every event and react to these events coming in and don't want to do a micro-batch mode. Now, there's a number of questions that have come in from the audience. Let's try and deal with as many as possible. So there's a question that says, what is the query performance after applying real-time updates? Not clear on that, but the query is more offline, right? The query is coming from the index, and we've seen pretty amazing instant response for even terabytes of data on the index and persistence. And there's an aspect of trade-off, of course, as many of you that are familiar with Storm may know, in terms of performance. If you increase the size of events, the performance of the entire system that's dependent on Storm would is a trade-off between the event size and the throughput. So we've seen in a telecom case, we've seen even kilobytes of event sizes coming in. We've been able to process hundreds of thousands of events per second with multi-kilobyte event sizes in a fairly small cluster of 10 to 15 nodes. There's a question on, is Hive an option as well for persistence? It's an option from our perspective, yes. Now, in terms of performance of Hive as a real-time data ingest, not sure if that will be the most optimal.
People have tried HBase as in some cases for some of the real-time stuff, but I've not seen Hive being tried. Yeah, but I don't think that's a viable option. Yeah.
Correct. So in terms of keep in mind, folks, that whatever persistence system you need to use, it has to react in real time, and it has to be a fast ingest store so that you don't choke the throughput of the whole system. Now, there is a request for showing a demo from a user perspective, and the log analytics demo that we showed you was a user perspective in terms of an application from an application built on the system. Puneet, do you want to address any questions that you're seeing here?
Yes. So there's I think there's one question on the positioning of the product. I think that might be probably quite relevant for us. Maybe we should address that.
Oh, yeah. Great. What is the positioning of the product? Log analysis service or batch query with real-time update or real-time analytics with real-time update? So here's the deal, folks. We showed you a picture of the platform, and I should have stepping through the slide here. So look at this picture, right? This is a real-time streaming analytics platform that can be used for any use case, any application, any vertical. So you put this platform in a financial services environment, on the telecom environment, or the retail environment, and you can build a variety of different applications that process real-time data, and these applications could also dip into batch and combine batch and real-time data to give you a joint blended result. So it is StreamAnalytix is a platform on which you can build any streaming analytics application. The log processing application we showed you is one such example of an application that we have chosen to now build because there's been a specific demand from a number of customers. But it's just an example of an application. You can build other applications similarly, and the whole point of this is to make application development and deployment and Storm easy and fast. And we are treating the log analytics application as a separate line item, so we sell that with a separate pricing, and the platform is a separate pricing. There are two different line items there. And over to Puneet for addressing a couple of questions.
Thanks, Sam. So there was a question about, can the provisioning tool can that be used for provisioning this entire system in AWS? Yes, the provisioning tool can deploy it on AWS if that's where you want it to host, or if you wanted to do it on an on-premise VM-based or bare metal, the provisioning tool can handle that as well.
So we'll probably take just one or two more questions and close the webinar since we've already hit the 50-minute mark here. There's a very blatant question about replacing Splunk. Could you replace Splunk? Answer is yes, we can definitely do that. A lot of questions from our real live customers are coming in with exactly that question. There are a couple of live trials we are in with that particular mission. Answer is yes, please engage with us and write to us. Your architecture shows getting data from Rabbit and Kafka. Can I instrument my own code to publish data to the platform and build my own apps on my own metrics log data? Yes. Answer is yes. It's not just Storm and Kafka. You can have other queuing systems inserting their data into Storm, and you can build applications on that. One of the things that we want to highlight here is the system is based on Storm currently. As part streaming hardens up and becomes a much more viable candidate for deployment in enterprises, and that would obviously be with actual enterprises doing it themselves, multiple cases of that happening. StreamAnalytix will abstract that into our scope, and will give you the same benefit of abstracting StreamAnalytix, abstracting Storm and Spark and any other streaming technologies that come up as viable candidates under the StreamAnalytix abstraction. And you see in this picture, that's what's illustrated, right? We have a timeline on the bottom. What you see here is StreamAnalytix based on Storm now, and we clearly will be incorporating other technologies that become important for the enterprise community that's looking at open source options.
Adam,
with that, folks,
we can answer.
Okay, go ahead.
Question on is Storm good for joins? So Storm, especially on top of Esper on top of Storm, is very good for joins. You can do all kinds of joins on top of that.
Great, excellent. Thank you, folks. You can continue to come to us for questions on our platform, StreamAnalytix or Storm and Spark. We are a consulting and services company that's Impetus, and have provided all our experience, knowledge, best practices in the form of this product called StreamAnalytix. So StreamAnalytix is the product we're selling, as well as you get the benefit of a very experienced, deep expertise SI that can come in and customize the whole platform for you for your particular environment. With that, I'm going to go to the last poll here. Please give us your rating. We'd love to hear your feedback. Provide your rating for the webinar content and experience, 5 being the best. And any other textual mode input you have, please go ahead and submit that. We will be live showing this system off in the DataStax Cassandra Summit coming up next week. And we'll see many of you there. And until later, take care and feel free to interact with us using this email ID, inquiry@streamanalytix.com. Thank you so much for spending your valuable time today, and we'll see you soon. Bye.